Hello everybody. I'm going to be presenting to you all today. So just to give you a little bit more information on myself, I'm a 9th grader, and every year I do a science project with my father. And after coming to the all hands on deck meeting here at MIT, we decided to create a draw cam, which is what you can see here. Now, before I get more into the draw cam, I have a quick video showing our experience making it. So, marine exploration is very difficult, and there are many reasons. First, there's pressure, which only increases as you go down. There's salt water, which is very corrosive, and just a single drop in the wrong place is enough to completely fry a circuit. Then there's also the problem of autonomy. So after a certain depth, about 100 meters, it gets really expensive to have a cable attaching your equipment, the camera, to the boat or wherever you are. So supplying power and being able to control the camera becomes much harder. That's why it must be able to supply itself with power and to know when to release it so it can come back up. So our drop cam features a GoPro Session Pure 5, which is controlled by the microcontroller, which is an Arduino Maker Wi-Fi, via Wi-Fi. It has two 1500 lumen lights, and it has two switches. The first one is this electronic switch, which turns the camera on. And then there's also a magnetic switch, which tells it, hey, we're going to drop you, so get ready, and it just tells it to start. Then to release it, we have two methods. The first is a burn wire. It's a cable that when supplied with enough electricity breaks, which causes the weight, which in our case is a biodegradable bag of cotton with sand in it, to fall. And when it gets released, then the camera just rises and we can recollect it. But if that doesn't work, then we also have a galvanized time release. So this, after a few hours, dissolves in the salt water, which also releases the weight. And here, for the enclosure, we used an aluminum cylinder, which is capable of going to 1,000 meters. However, the dome end cap, which is this transparent part, is made out of plastic, so it can only go to 500 meters, which is pretty good, but it could be better. And the ideal material for this will be borosilicate. And we also have a flat end cap, which is just what covers this side.
He's over there.
It's over there. It's right here. So here's a diagram showing how all the components work together. Just a diagram. And the way it all works is that if you want to actually drop it, the first thing you need to do is turn on the camera. And it's also very important that it happens in this specific series of events. So you turn on the camera, then after turning on the camera, you can turn on the switch. And once it turns on, the Arduino automatically connects to the GoPro. So when it's connected, you can put the magnetic switch, which starts a countdown. Now this countdown is the amount of time that the camera will take to drop to the surface of the water. And this can also be changed in the code before you actually throw it. So when that countdown is done, by then the camera should be at the surface or arriving, and then when it's over, the lights turn on. And
at the bottom, you mean, with the surface?
Yeah, surface, I mean at the bottom, sorry.
Yeah. Sorry.
I'm feeling my teenage angst right now.
You're doing great.
Yeah, thanks. So anyway, the lights turn on, and the camera also starts recording, and after a set amount of time, maybe 15, 40 minutes, an hour, whatever you want, after that amount of time, the lights turn on, turn off, the camera stops recording, and then the release mechanism starts, the burn wire, which allows the camera to just flow back up, and you collect it. So far what we've been able to do is we've coded the microcontroller, We have spent $1,300 in buying the equipment, and we've successfully tested at 50 meters of depth. But next, we would like to test at 500 meters of depth, which is the depth that it should be able to go to. And we will also be making everything open source, so that anybody who wants to make it will have the designs and the instructions to do it on their own. And also, moving forward and creating the Blue Eye 2.0, we will be exploring ways to lower the cost. We will also add a mechanism to take a sample of the biome of the water. That way you can test for things like pH, salinity, see if there's any microorganisms, and we will also be adding different lights to see if there are any bioluminescent organisms, like say plankton, for example. Now, I would like to open the discussion to: can DIY bio and GIY bio solve climate change? So there are different ways that they help climate change. One is monitoring the oceans, which is how the camera helps. So while it may not directly help us, what it does tell us is how climate change is affecting the oceans and how the oceans are doing. So now, if anybody would like to say anything, their opinion on this, please go ahead.